Hello, everyone. So this week, we're gonna deal with the law of Boolean algebra. But before we do, I just want to introduce a couple logic gates here. We already talked about the AND and OR gate. So now we have a new gate called NAND gate. That means AND NOT. So just like an AND gate, but put the little zero in the front, indicate the NOT gate. The AND gate, but it's NOT gate. Just OR gate, but put NOT gate in there, so become an OR gate. And the next one is SOR gate. That means the OR gate with the combination of A naught B plus AB naught. As you can see that just like OR gate, but have a little curved line between those OR gate. Okay, and then we have XNOR gate. That means SOR gate, but put 0 at the end, indicate the NOR gate. So XNOR. That means A naught B plus AB naught, and everything is NOT gate. Okay, so look at the example over here. You see that SOR gate. So this is SOR gate. That means A naught B plus AB naught. And then you have a C naught over here, and this is OR gate, so you add all together. So you got A naught B plus AB naught plus C naught. So that indicate for the SOR gate. Okay, so this week I'm gonna talk about the law of Boolean algebra. It's gonna cover from page 229 to 236. All right, lesson 20 to 22. This is a long unit, so what I'm gonna do is I'm gonna break them down to the short assignment, only 15 questions from 229 to 236. All right, so let's look at the Boolean law, everybody. So I'm gonna show you the screenshot that I'm gonna have for this lesson. Okay, so we're gonna deal with laws of Boolean algebra. So you got 12 laws over here: the redundancy law, the commutative law, associative laws, double negative laws, complementary laws, consensus law, intersection law, union law, De Morgan's laws, and distributive laws, absorption law, and common identity law. So, all right, it's the reason we have a laws of Boolean algebra so that you can simplify the Boolean expression, make it simple in your designing your circuitry. So I'm gonna begin to talk about redundancy law. Okay, as you can see the law right there, A times A equal A plus A equal A. For example, if A equals 0, so A times 0, 0 times 0 equals 0. If A equals 1, then 1 times 1 equals 1. All right, and A plus A equals A, that means if A equals 0, 0 plus 0 equals 0. And if A equals 1, then 1 plus 1 equals 1. So that the redundancy law, you don't need, when you do simplify that, you get rid of the one look the same, and then you simplify it. So in this case, you got 3A here, so I'm gonna get rid of it. 2A, let me, using the pen here. So we can get rid of this one and this one, so the answer is A plus B. All right, in this case, you got 2BC here, you get rid of 1. All right, and you got 3Ds, so D times D times D times D equals just D, right? 0 times 0, 0 equals just 0. And if D equals 1, that means 1 times 1 equals 1. So in this case, the simple expression would be A plus BC plus D. So if they're repeating, you just try to simplify it. In this case, you got C repeating, redundant. So get rid of 1. two of them B here, get rid of B, so that you end up only have A, B, C. So redundancy law, try to simplify by cross out the one that repeating. All right, so I'm gonna go to new law, which is commutative laws. Commutative, that law, just like in our typical algebra expression, A times B equal B times A. You're just changing the position, but the value does not change. A plus B equal B plus A. All right, so in here, I'm gonna change A put down in front of B, so I'm gonna write out easy to see it. I write out A plus B. I put A first and then B second. So then I can see A and A redundancy, so I just get rid of one, and the answer is A plus B. And here the same thing, you know, either AB or BA, so same term. So you can just write out AB plus AB, because you just switch it. So they both the same, but they're switching the position, plus AB not. Okay, so you got 2AB redundant, you get rid of one. So when you add together, it become one. All right, and this is a new law, and we can explain about this one later on. Okay. So right now, just commutative, you're just changing the position. Instead write out BA, I write out AB. So that look, we can apply redundancy law. And we can talk about AB plus AB not later on. Okay, so complementary, yeah, this is complementary law right here, which is, you know, which is, I just did it over here, but AB plus AB not equal one. All right, so complementary or inverse law, you know, either you multiply A equal 1 and A not equal 0. So 1 times 0 equals 0. If A equals 0, the A not equal 1. So it doesn't matter which one, 0 or 1. When you multiply the inverse of it inverse, you have 0. And when you add together, so you multiply together, it becomes 0. And then the answer is 0 plus anything equal that number, so C plus D. 0 doesn't have any value when you add together with C and D. All right, in this case, you have one AB and then AB not, so look like apply the second rule right there for the complementary or inverse law. So the answer is 1. For example, all right, union law. Union law, it encompasses everything. So in this case, it doesn't matter either B or C, doesn't matter either it has 0 or 1, but 1 is the highest number here, so 1 is the union. So when you add together equal 1. All right, regardless B or C. When you see 1, you cross the other one. You don't have to worry about that. So in this case, you got 1 plus B plus C plus D. So whatever B and C and D, you add with 1 equal 1 is equal A. A times 1 equal A. All right, union law. So every time you see number 1 in addition problem, then you just cross everything and use 1 as the union law. Distributive law. This one you got 2 rules, okay? And I'm going to explain how they come up with this one. So rule number 1 is when you have A multiply B plus C, called distributive law. So you multiply each element inside the parenthesis. A times B equal AB, and A times C equal AC. So that's very simple enough. Now, when you multiply the addition inside parenthesis, then become addition. Now you got A plus BC, and if you want to distribute it, become A plus B times A plus C. And we're gonna prove that one. So then you know why did it come up with this one, okay? So let's say like here, you have, I'm gonna, using this expression to your left, all right, and then I'm gonna prove it. It's gonna be equal A plus B times A plus C. All right, first of all, B plus 1 equal 1, the union law. So it doesn't matter what, either B equal 1 or B equal 0 when you add with 1 equal 1. So I substitute A times 1 or equal A, but then 1 equal B plus 1, so then I add B plus 1 in there. And then you will distribute it. So A times B equal AB, A times 1 equal A, and plus BC. So I'm done with the first step by substitute B plus 1 equal 1 and multiply by A. And then I have that one. Now, I only have AB and BC, but I don't have anything with AC, so that one I'm gonna substitute C plus 1 equal 1 to C. All right, so I need C in there, so then put down 1 times A equal A, but 1 equals C plus 1. So then I multiply together, distribute it. AB leave it alone in the first term. Second term, A times C equal AC, A times 1 equal A, and plus BC. Now I got AB, AC, and BC, but I don't have enough A in here, so I need AA. You just have to have an AA, AB, AC, and then BC. You got to have a full term. So in this case, I will have A times A equal A. It doesn't matter either A equals 0 or equal 1. When you multiply by itself, they call identity law. We learned this one from earlier. All right, so I substitute A and I multiply by A in there, equal A, right? That, remember, redundancy law. And A, you can cross it, 1A, make it 2A, make it A plus B, multiply, not add over here. A plus B multiply by A times A plus B times A plus C. Okay, so that is the answer. Okay, so every time you see A plus BC, you can say A plus B times A plus C. A plus B times A plus C. Always remember that. All right. So we got, let's do some example here. All right, so this one is ABC, just leave alone, ABC. This one distributive rule number 1, which is right here. So A times BC equal ABC. And AD plus AD, you multiply by each term inside the parenthesis. So this one is a redundancy law. You can cross one. So your answer is ABC plus AD. All right, so that's a distributive law. You have to have two different rules. Case number, rule number 1 and rule number 2 in the case 2. Now, De Morgan's law, we can AB not, A times B not, the whole line, you break the line. You break this line. So when you break the line, you change the sign. Break the lines and change the sign. So you break it AB, change A times B equal A plus B. So you see that I have it, A break the line become A plus B. Now, A plus B, not the whole thing, break the line, become A times B. So do like that, it's not the same. All right, so you make sure that when you break the line, you have to change this one to addition, not multiplication, because we call De Morgan law. So I apply the truth table here. All right, so I got AB, and I want to know AB not. Well, A times B, that means 0 times 0 equals 0, and AB not equal 1, opposite of it. 0 times 1 equals 0, opposite equal 1. 1 times 0 is 0, opposite is 1, and 1 times 1 equal 1 times 1 equal 1, and opposite equals 0. AB not equals 0. Now you want to add together A not B. So 1 plus 1, because you do not. So 1 plus 1 equal 1. 1 plus 0 equal 1. 0 plus 1 equal 1. And 0 plus 0 equals 0. All right, so as you can see, the blue one, the light blue one, they are the same. And I can do the same thing with a plus 1 not. The whole thing is not. You break them, break the line, change the sign. So from addition, change to multiplication. And I apply the same thing, and I check by truth table, and I come up with the same. Okay, from now on, when you break the line, you change the sign. Just from multiplication, change to addition. From addition, change to multiplication. That's all you need to know. Okay, so let's apply this one. I break the line, change the sign. So I put change the sign. Break the line, change the sign. And plus a like that. Now a naught plus a, so they are opposite each other. When you add together equal 1. So it write down equal 1 plus a. 1 plus a. But this is union law, so it doesn't matter a 0 or 1, the answer equal 1. So you apply De Morgan laws and union law together, and the answer equal 1. Break the line, change the sign. So you got a, b, change the sign to multiplication. Break the line, change the sign. All right, and then you multiply by a, b, b, b plus d. All right, redundancy law, get rid of that one. All right, so you got a naught, b naught, b, a naught, b naught, AB, BA or AB, the same thing, BA or AB, A naught, B naught, AB, BA, doesn't matter, and put out D. All right, so A naught, B naught, so this is equals 0 because you got 0, anything multiplied 0 equals 0. So if B equal 1, B naught equals 0, so always have a 0 in there. So the answer is D. All right, so De Morgan's law, follow one line, break the line, change the signs. All right, and then you have identity law, intersection or identity. A times 1 equal A, and A times 0 equals 0. That's very explanatory right there. So AB times 1 equal AB, and C times 0 equals 0, so the answer is AB. Simple law. Double negative, if some of you already know this one, if I say A equal 1, so A naught equals 0. So you got A double naught, so 0 naught is become 1. So A double naught, A double become 1. A double negative become 1. All right. So in this case, double negative AB equal AB, and AB plus C. All right. That's the way you go for double negative. We talk about associative. Associative is more like when you're changing, when you do the grouping, just like in algebra. If in algebra, if I got 83 plus 150 plus 17, if you add from the left to the right, it's going to be more difficult. 83 plus, not difficult, but it's take a longer time to do it. So you rather add the 83 and 17, you group them together. So I put down 83 plus 17, and then I plus 150. So 90 plus 10 equal 100. 100 plus 150 equal 250. So this one will go faster when you're changing. So if I put down AB, A plus B plus A like this one, you rather group together A plus B. So you know this, group them together. So you can see, hey, A plus A, that means you redundancy. So you got A plus B, two of them. All right. So associative law, that means you're changing them, the grouping. You change the grouping. Before you group B and C, now you group A and B. Same thing with addition, A plus B plus C. You can either group A plus B or you can group B plus C. Whatever convenient that you can see better, all right? Consensus law, now instead BC times 1 equal BC, but instead of writing 1, I write out A plus A naught. And then you just use a distributive, you multiply that one. So BCA, I can write out ABC because that is a commutative, that means you switch the position. BCA is the same as ABC. And next one is BCA naught, I put a A naught BC. All right, and then I can group them together, AB, and not a grouping, but I try to do commutative law. That means you go with the list ABC and you got AB, so we go with AB, all right? And then AC and ABC, we go with AC. We go with the list one, so that one, the answer is AB plus AC, A naught C. Okay, so absorption, AB and BC, we absorb. AB absorb ABC. All right. All right, so, and then that's a consensus law. So if you have something right here, you are gonna absorb what you're gonna absorb. You, in consensus law, you got A naught C, so you get rid of CD here. So the answer is AC plus A naught D plus BC. Okay, so that's the answer. Consensus law. I mean, you practice a couple times, you will get used to it. All right, so those are 12 laws. We're gonna do more practice, giving some more example, and do more practice on 15 problem I kept to you. You know, you look through this one again, make sure that you're familiar with all the 12 laws in here. Take a while to get used to it. More practice, the better. And then try your best. As always, email me or meet me in team if you need some help on this question. I posted the 15 questions for this week, and then I want to post a short quiz soon. All right, have a good week, and hope everybody doing good. All right, bye-bye.